All right, good morning. To all of you Avid students who are on the field trip today, thank you for those of you that reached out letting me know that you were going to be gone. I'm making this video so that you're not missing out on me actually teaching you, but you guys are smart kids and you're very capable, so I know that with this and Zern that you'll be caught up and ready to get back at it tomorrow. So today's lesson, if you want to fill out your agenda, is the circular grid, lesson 2. Our learning targets are: I can apply dilations to figures on a circular grid when the center of dilation is the center of the grid. Your homework, especially for those of you that are gone, this will be able to help you a lot, is to complete through lesson 2 on Zern, the math chat and the Tower of Power. Now, when you're watching the math chat, please make sure that you're watching the videos before you skip ahead to the problems. That's actually going to help you understand what the problem is asking you to do. So here's your agenda. Pause the video if you need to write this down. Otherwise, I'm going to move on. So hopefully you'll have your packets. Hopefully I will have given you one. So just please follow along. This is your warm-up on your front page here. It just has this grid on it. And I'm asking you, okay, to take a couple of minutes. So when I say to pause the video, go ahead. Write 2 things that you notice about this grid and 2 things that you're curious about. So this kind of looks like unlike anything we've talked about before. Think about how is this going to relate to our math class. So pause the video, take 2 minutes to write down 2 things you notice and 2 things you wonder. Okay, otherwise we'll move on. Here we go. Okay, so this graph is pretty interesting, I think. See all these circles, it kind of looks like a spider web, right? All of these lines, okay, all of these straight lines all meet in the center. Okay, that's going to be really crucial for what we're talking about later. And look at all of these circles here. Okay, some are bigger, some are smaller. Okay, they keep going bigger the further you get away from the center. All of the centers of the circle are the same too, right? So if we were to take a look at, say, this smaller innermost circle, okay? If I were to be using a compass where I use the pencil and draw, the center of the circle is going to remain the same. It's the same with this really big circle all the way on the outside. Okay, the center is still the same. So that's kind of neat about this grid too. Also, the distance from one circle to the next is always the same. So if I were to take a ruler, okay, say, and measure this length right here, okay, from the innermost circle to the next one, it's going to be the same length between the circles as all the way out here. Okay? So this is essentially a grid. You could count this as 1 unit. Okay? And then this would be where you count 2, right? Because here would be 1. This would be 0. Think about like an axis of sorts. Okay? So going out another unit from 2 to 3. Another unit, 3 to 4. All the way out in every direction. Now this graph just has these lines here, but you could make your own line if you really wanted to. Okay? Splitting the middle, that would be a half unit, just like we do on a regular square grid. Okay, pause the video if you want to take notes or take a screenshot. Otherwise, we're moving on. So I want you to think to yourself, okay, what happens when you just drop a pebble in a pond? Okay, what happens to the water? Okay, I want you to just think about that for 15 seconds. You're probably going to see something like this. Okay, drop the pebble. Okay, this is where the pebble lands. We'll call this the center. Okay, and it has that ripple effect. There's circles coming out, and the more that the more waves there are, okay, the bigger the waves get, the further they go away from the center. Okay, but they're all pretty much perfect circles, all leading back to that center. Okay, looks kind of similar to this right here. Imagine that I'm dropping the pebble, okay, right at P here. Okay, all of these circles are those ripple effects in the water. Okay, so just trying to give you a real world example here. Okay, so how does this look similar? I kind of just spoiled it for you, but I'm hoping that you're able to see the similarities. Okay, I drop the pebble, okay, ripple, okay, and then they keep going out, they keep extending while the center is remaining the same. That pebble didn't move. The pebble isn't way out here now. Okay, it drops straight into the center. Okay, this is P. It's going to be called our center of dilation. Okay, P, this is your new term. You might want to write this down in your notes. P is the center of dilation. Okay, so this is also in your activity 1 in your note sheet, so you might want to flip your papers over now. Okay, if you're using highlighters, I know Avid really likes to use highlighters, you are going to want to highlight these bolded terms, center of dilation and dilation. And maybe you do it in one color, center of dilation, and then you highlight P the same color, because that's what we're talking about here. Okay, so P is your center of dilation. That's where everything is coming out to and from. Okay, like we just talked about, each circle away from the center is 1 unit. Okay, so this length right here, this would be 1. Okay, 1 more to where this circle C is, this would be 2. If I were to measure on any side length, it's 2 units from the center. Okay, it doesn't matter where I'm going from, as long as it's coming from the center, it's 2 units. Okay, so what I want you to do is just right next to this graph on your paper, I want you to count, okay, how many units to the circle C, okay, this blue one right here, it's just going to be dark on your page. How many units from the center of dilation is every point on C? Now we just talked about that, it's 2. I want you to just count in your head all the way out to D. Okay, so we can count it out. 1, 2, 3, 4, 5, 6 units. Okay, in order to check our work, we can find a different line. 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. Okay, and remember, each of those units is where those circles are intersecting with those straight lines. The straight lines come back to the center of dilation. Okay, so in this next activity, when I'm saying on the circle, I mean on this dark line here. Okay, so on the circle, this could be any part of the circle as long as it's that curved end. Okay, and it actually doesn't even need to be where one of those rays intersect. You could do a half unit here. You could do a half unit here. But when I say on the circle, okay, let's just pretend that I'm working with D right now. I don't mean somewhere in here or somewhere way in here. I mean actually on the line that extends the same amount from that center of dilation. So that's what I mean when I say on the circle. Okay? And additionally, when I say that a ray starts at a point and goes forever in that one direction, all of your rays start at center point P. Okay? So imagine these straight lines that extend out through all of these circles. Okay? All of them extend from that center of dilation, point P. Okay? So a ray, you guys probably have seen it something like this. Okay? It has a starting point and then it extends in one direction infinitely. Okay? It's the same concept here. P is our end point, our center of dilation. Okay? Take a picture, take a screenshot, take some notes. Okay, so this is your activity 1. I want you to do this in your packet. Okay, you have this little grid here. The first one says draw 4 points on the smaller circle. Okay, not inside it, but on the circle. And label them E, F, G, and H. It can be anywhere. Okay, it might be easier to try to label it in accordance with array, but you can write these anywhere. Okay, so draw 4 points anywhere on that circle C. Okay, and then what I want you to do is actually to draw the rays that intersect with those points that you just drew, all going back to center P. So I'll just give you an example. Okay, I'm on circle C. I'm going to draw a point here. It's asking me to label it E. Okay, then I'm going to draw a ray from the center point P that intersects the line that I just created, or the point that I just created. Okay? Then I want you to continue that ray out, okay, on that same line that intersects back to the center of dilation. Keep it going through circle D, this larger outer one. Wherever it intersects the circle, on the circle, I want you to label that point, okay? If this is E here, I want you to label this E prime. Okay, prime means new. New, we're continuing out. Imagine that I dropped the pebble. Okay, after 1 second, that wave is at E. After 3 more seconds, that wave is at E prime. Okay, so I want you to do that for F, G, and H. Okay, do the same thing where you're drawing the ray and labeling your points. Okay, when you've done that, I want you to complete this table in your notes now. Okay, in the row labeled S, so that's all of these right here. Okay, I want you to write the distance in units between that center of dilation P and the point on the smaller circle in grid units. Okay, so let's go back. If I had my point E right here, okay, so I want you looking at your table in your notes right now. I'm counting 1 unit, 2 units till it intersects with E. So if I were writing in my notes, okay, here's my E. Okay, here's my E. I'm gonna write 2 units. Okay, wherever my F is, I'm gonna do the same thing for the smaller circle. Okay, then you're gonna do the same with those other prime points, E prime, F prime, G prime, H prime, with the larger circle. So if my E prime is way out here, okay, my ray intersects both of those points, 2 different circles. Okay, in the L row, okay, I want you to complete or tell me how many units from the center of dilation E prime is. So I would count out 1, 2, 3, 4, 5, 6. So under E in L, I would write 6. Okay, please complete that for the other points that you just did. Okay, hopefully you pause the video and you come back now. If you haven't yet, please pause and then we'll talk about number 5 now. Okay, question 5 is asking, the center of dilation is point P. Okay, that's that center point in that big grid. Okay, what is the scale factor that takes the smaller circle to the larger circle? Okay, so scale factor means I'm going from the smaller one to the bigger one. What do I have to multiply by? Okay, every unit is going to be multiplied a certain number, okay, to give you to the bigger one. So I'm going to take C, I'm going to multiply every point by some number, and then every point is going to grow out to become D. Okay, so here's my E. It's 2 units from the center of dilation. Here's my point E prime. It is 6 units from the center of dilation. So my 2 numbers that I'm comparing here are 2 and 6. How do I get from 2 to 6 by multiplying? Okay, whatever number that gives you, that's going to be your scale factor. Okay, so in this case, to get me from 2 to 6 by multiplying, 2 times blank equals 6. In this case, it is 3. So the scale factor should be 3. Okay, because every point on this is multiplying by itself 3 times. Okay, so imagine, okay, here's 2. Okay, I'm going to draw these in different colors. Okay, here's 2 more. Here's 2 more. Okay, how many units of 2 do I have? 1, 2, 3. Okay, that's my scale factor. Just take a few minutes to fill this out. Okay, so something we should notice here is that all of the S's should be the same for E, F, G, and H. Okay, they're all 2 units away from that center of dilation. Okay, same thing with L. They're all the same number of units away from that center of dilation. No matter where you put it, okay, these were just some samples. You could have put it here, you could have put it here, you could have put it here, it doesn't matter. Okay, all of them are 6 units. Okay, and when I say unit, I'm talking about the distance between circles on one of these rays. That's 1 unit away from that center of dilation. Okay, so here's your important takeaway from this activity. The scale factor of this dilation is 3. So the distances from the center of the circles triple when that dilation is applied. Okay, so like I said, to get to this circle C, it's 2 units. If you triple 2, triple meaning multiply by 3, you get 6. So I had 1, okay, double it, triple it. Now we're at circle D. Okay, so the larger circle is the dilation. Dilation means that it's growing or shrinking, it's changing size. Now the shape stays the same. These are both circles, right? Okay, but the size is changing. Okay? The larger circle is the dilation of the smaller circle. Pause here, take a look at that, make sure you understand it. Then we're going to move on to our next activity. Okay, now I want you to flip over your papers. Okay, so you should be on activity 2 now. Okay, you should see on your paper this here. Okay, now I want you to skip number 4 on your packet. We're just doing 1, 2, 3, and then 5 and 6. Okay, so skip number 4 in your packet. So your first task is to dilate each vertex of this polygon. Okay, this is a polygon, 4 sides, 4 points, using this center P as the center of dilation and a scale factor of 2. Okay, so let's work with 1 just as an example. Okay, we just worked with 1 where the scale factor was 3. Now we're doing it with 2. Okay, so I'm going to go to B to start. Okay, here's my center of dilation, point P. Okay, I'm going to go out, count how many units it takes to get to B. Okay, so it's 1 unit, 2 units. Okay, so my scale factor is 2. So it's 2 units times the scale factor gives me where my new point is. Okay, or my prime point. Okay, so 2 times 2 is our scale factor. 2 times 2 is 4. So that's where my B prime is going to be. 4 units from the center of dilation. Okay, so I'll draw this in a different color. So on this ray, okay, 1, 2, 3, 4. This is where my B prime is. Okay? So then you can substitute any number in for that number of units away, but the scale factor stays the same. Okay, so let's just say I'm going with D now. Okay, it's 1, 2, 3 units from the center of dilation. 3 units. times a scale factor of 2, my d prime, my prime point, is going to be 3 times 2, 6 units from the center of dilation. Okay, so now I'll draw this in red. So it's 1, 2, 3, 4, 5, 6. D prime, label it. Okay, do that for A and C as well. And then I want you to connect these new vertices. Okay, so you're connecting B prime to C prime, C prime to D prime to A prime to B prime to make a dilated, a prime polygon. So complete that on your paper now. Okay, let's come back. Okay, now your question 4, but on your paper it's number 5. Okay, we're still back with ABCD, it's polygon ABCD. P is still our center of dilation. Now, I want to dilate each vertex with a scale factor of 1/2. Okay, so this is going to be half as big. Okay, so we'll do units times the scale factor equals the prime point. Okay, in this case, my scale factor is 1/2. Okay, so let's work with B now. Okay, we're doing B. B is 2 units from the center of dilation. Okay, with a scale factor of 1/2, it's essentially dividing by 2. Okay, 2 times 1/2 equals 1. That's where my prime point is going to be. So instead of 2 units, instead of going past it, now we're just going 1 unit from the center of dilation. Okay, so I'm going to mark my B, my new prime, as point F. Okay, I want you to do the same. You can use this formula. Okay, the scale factor is going to stay the same here. Okay, so you can do the same with A, you can do the same with D and C. And then do the same thing where you're connecting, okay, those points to make a new polygon. Take a couple of minutes to complete that. You can pause the video. Okay, so I'm hoping that your paper looks something like this. ABCD, the blue one on the screen, that is our original. Okay, when the scale factor was 2, okay, it's twice as big as the original. Okay, when I say scale factor, I mean that it's going to be times whatever that number is, as big or as small. Okay, so ABCD, that's our original. Scale factor of 2 gives us A prime, B prime, C prime, D prime. That's this larger green one. It is twice as big as our original. Okay, EFGH, that's the smaller green one. It is half as big because the scale factor is 1/2. Okay, so here's your rule of thumb. You might want to put this in your notes. Okay, when the scale factor is less than 1, okay, the scale copy is smaller than the original. Okay, so when my scale factor was 1/2, okay, it's smaller than the original. When my scale factor is greater than 1, okay, in this case it was 2, the scale copy, so you could say the prime or the image, right, thinking from last unit, is going to be bigger than the original, like A prime, B prime, C prime, D prime. Okay, so write these down in your notes. When the scale factor is greater than 1, the scale copy is bigger than the original. When the scale factor is less than 1, the scale copy is smaller than the original. So write that down in your notes, please. Okay. If you need to go back and pause the video, please do so. Now for your homework, you just need to get through Mission 2, Lesson 2 on Zearn. Through the math chat, do the digital lesson in your notes, okay? When it says to do that, it says, okay, open up your notes. I want you to actually do it. And watch the videos too, it's going to help you, okay? Then I'm asking you to do the Tower of Power, okay? And the exit ticket in your packet. Okay, obviously we're not doing this in class, this is homework. Okay, this should take you about 15 minutes if you dedicate some time and full attention to it. Okay, I know you all can do it. If you have any questions, please send me an email or come see me. I'm happy to answer any questions. I hope this helped, and I hope you enjoyed your trip to UWM today. It's a great campus, and yeah, keep up the great work, guys. Thank you.